Alrighty, it is day number 3. I've been able to spend an hour or two each day on this project. So, just to catch up on what I've been doing is I cleaned off the gasket goo from this cover. Got a lot of black stuff throughout, so I washed it all out with WD-40 and a rag and some paper towel, then some compressed air. Oop. Don't forget this little O-ring there. Now I am doing the same on the cover here. Just in the process of cleaning up all this goo. So we want to make sure we don't let any get into the engine. So yeah, let's do another little. Actually, you know what? I have to get up close to this case, so the camera's not going to catch much. So I might just continue where I left off, using this to clean the case. Now remember, don't go gouging at the aluminum, because this is a steel blade. It'll cut this aluminium, no problem at all. So we don't cut, we scrape. We're we're using it as an adze in the old woodworking terminology. So we're scraping, we're not cutting. So we're always pulling, we're not pushing, because if you push, you'll cut the metal. If you scrape it, it'll take off the absolute minimum in addition to the silicone. Okay, so yeah, I'll finish this up. And then the next step after that is to pull the oil pump drive gear off. We'll pull that off, pull the chain off, pull the drive sprocket and the spacer off. We're at neutral still. And we'll continue following the directions and take it from there. So yeah, I'll be right back. Now I have cleaned the side of the case mating surface. I also took off the exhaust valve controller. It was just these 3 nuts. And the ABS controller was held in by this one here and this one here. Just made it a little easier to get to. There's not much we can do about this one. We can survive with that there. Let's see. Okay, so now we're going to have to undo this nut, that bolt I should say. Pull this spacer out. And every time I see a little drip or piece of silicone, I keep cleaning them up. I kept as much of it out of the engine as I possibly could, but there's always little bits that creep in, which of course can be solved by changing the oil. And after all, that is the entire reason for doing this. Well, a large part of the reason for doing this project. The fact that a dry clutch doesn't pollute the oil with sintered metal particles. And of course, why the hell not? Okay, so what we need to do is we're going to have to lock this in place so we can undo that bolt. If I keep turning this, we're going to start seeing oil coming out of this orifice, because that's after all what the pump does. Anyway, so let's do this. Let's see what we can use to lock this in place. Let's do this instead. And let's try not to drop anything back down into the sump. Although if we did, it wouldn't be that big a deal, because of course the drain plug is right there. But still, we'd rather not drop anything. I swear a huge part of being a good mechanic is keeping control of everything and being clean. Okay, so that's a little bit of, looks like it might even be green Loctite. That's unusual. Okay, so we'll keep this one handy because that's going to go right back in. I'll use a little bit of oil-proof thread lock. Okay, so let's see. We need some instructions. Let's review the instructions just in case. And so there we go. 19 Newton meters, plus or minus 10% for the tightening torque. So we need the spacer, the bearing, the drive gear, and the washer, number 47, which is, oh, and by the way, the bearing's already been pressed in. Makes things a little easier. So 44 has been pressed in, so 46 has been pressed in also. So we don't need the special tool. Spacer 47 doesn't have a part number. And keep everything oiled. And of course, the sprocket, the gear, and the gear driver, the pump drive, have to mesh up. Interesting. I hate it when they don't put part numbers on their instructions. So, I mean, it could be this one. Spacer, okay, that's helpful. Different kind of spacer. This is a spacer too. We'll have to take a look and see which one it is. I mean, that's a spacer also. So let's see. So it's not that one. Could be that one. And that, okay, so that spacer pushes that surface up a little. I don't know if you can see that, but that's possibly the one. Yeah, so that way, yeah, I suspect that's the one, because that way, if I apply pressure to this, to this and the bearing, this spacer literally isolates the gear on the bearing like that. And we will put a little bit of oil on everything. But let's just double check. Both steel. Sometimes, yeah, well, damn it. Could be this one. Yeah, let's, okay, so this is the one that was in the bag. so that isolates the gear from the bearing, so regardless of pressure on the nut, this nut pushing down on this and the clutch, it won't cause the gear to bind, so that's what we want. The problem is that other one is just a different OD. Let's see what we can see here. You know what? Let's see if we can look through the instructions any more carefully and see if they've got a description of the part number for that part number 47. I'm starting to think this is it, not this one. So I'm going to look at the instructions and hopefully find what we need. Yeah, see, without the spacer, by pushing down, if there was pressure on the clutch, it would smush up against, it would smush this surface against this surface, and we don't want that because that'll restrict rotation. We want the bearing to isolate the gear. Yeah, we want this space here to be completely taken up so that this part rotates freely on the space on this spacer. So yeah, I will be right back and we will continue with the proper part. 421A. I took a very close look through the instructions and there is no mention of the part number for part 47. So it's not really saying which spacer it should be, but it did point out that these three components go together. So I'm going to take that as a process of elimination. This spacer and this O-ring go together, and then a spacer is supposed to go over the top. That just happens to be exactly the same diameter. So I'm going to assume for now, until we find out otherwise, that these go together. So 421A is going to be part number 41. So we've got spacer, O-ring, spacer, and then the bearing. And it doesn't say the part number for 41, it just says number 41. Not very helpful. Surface 43A. So 43A is not a part, it's a surface. Referring to the gap designed to cater or to fit that O-ring in. Yeah, not very helpful, but we will figure it out. If necessary, I'll assemble it. If it's wrong, I'll disassemble it and start over. That again is part of the reason I'm doing this, and chose this project over something else because there was just so little information that I could find. Anyway, so let's see. We'll pull the oil pump drive sprocket out. It shouldn't be too difficult. There we go. We're going to put that right back in. That's the old one. Wow, there's no bearing in there. That's just a bushing. It's already got some wear on it. Wow. I don't know if you can see that, but you can already see the wear on the inside. You can see where the bearing was actually... Wow, it's weird wear. Odd. Okay, so that's the old part. And this is supposed to come off too. Yep, there it goes. So, a gallery for oil pressure in each one, but a bearing is going to provide less rolling resistance than a bushing. Well, depending, although sometimes it's better to use a bushing with oil pressure than a roller bearing. Okay, so we've got this. So the instructions say the spacer, then the needle bearing, and then the sprocket. Just happen to have a little bit of oil here from experimenting with the pump. There we go, nice fit. I pumped some oil out of the sump and into this little cover. There we go. Put some more on there too. Now, let's do it this way, shall we? That gear. There we go. Rotates nice and freely. It's kind of chilly here. Oh, there goes the oil from the pump. Okay, let's get some Loctite for this spot right here, and then we will continue. Oh, there it is. Yes, I need to head down to my place in the next day or two and pick up my lift. With that, I'll put the lift in here, put the bike on it, lift the whole thing up, and I'll get a much better access. But until then, we can at least keep busy. Okay. Brand new, let's see, surface insensitive thread locker. So this is supposed to be the equivalent of the Loctite number such and such that is oil proof. Just clean the threads off, make sure there's as little goo in there as possible. Let's see, what else after that? Threads weren't that dirty. Oh, and I've got to get that torque wrench too. I think it said 19. Should have got that first. Not sure if this one will be able to go that low. There we go. Now, where was that? Thought I brought that adapter over. Oh, I put it in the bigger socket. And I've got my small sockets in my track toolbox. There it is. $19 Newton meters. Okay. I should leave this on here. Got so many of those adapters. Alrighty. Let's see what's next. We've got that, we've got that, we've got that, we've got that, and that. Now, number 47, followed by the main sprocket. We've got that, that, and that. Okay, 47. I hate crappy instructions. They're both the same ID, different OD. There's a part number on one of them, but it doesn't help because it doesn't give the part number of the piece required. So, I'm going to stick with this just so that it can give better access to oil for this bearing. And well, that one fits within the idea of the gear. And that would be out. Yeah, okay. That must be the one. Process of elimination. So I'll leave that one for later. On goes the drive gear. Nice firm fit. Let's tap that on nice and gently. Okay, so there's the slots. I think. Yep. Those gears now mesh perfectly. and the pump drive is engaged. Okay, so as I mentioned earlier, and thank you to the viewer who commented on the MV Agusta F3 800 being another motorcycle that has a reverse rotating crankshaft. So that makes the GPZ 500, this, and the MV. Clever fellows. MV that all have reverse rotating crankshafts. So we've got the crankshaft is right here. It spins in this direction. It spins this gear, which is now going in that direction, which makes this go in reverse. So this is spinning in reverse to the wheels, but there's another gear right here, another shaft, that therefore spins this way, which is connected by a chain to the rear wheel. So that's how the power is transmitted from the crank through the transmission to the wheel. Typically, this meshes with this, but that adds the torque and gyroscopic effect of the crankshaft to that of the wheels. By spinning the crank in the reverse direction, it generates opposite gyroscopic effect. So if you've ever seen the videos, which I recommend, if you haven't, take a look at bicycle gyroscope, or bicycle wheel gyroscope. If you've got a bicycle wheel spinning on a shaft, you can actually hold it just by one side of the axle, and the wheel will slowly rotate around the axis that you're holding it on. Just imagine what would happen if you had two bicycle wheels, one spinning clockwise and the other spinning counterclockwise on the same shaft. The torque and gyroscopic effect of each wheel would cancel out the other. So that would mean it would just drop straight away. You wouldn't be able to do all the funny gyroscope things that you can do if there's only one wheel. When you've got two motorcycle wheels rotating like this, they generate an enormous amount of force that wants to keep the motorcycle upright, which can be great if you're only going in a straight line. But if you're trying to turn corners, it's resisting the change of angular direction. So every time you want to turn a corner, the gyroscopic force of the wheels is resisting that effect, or resisting that effort to turn the corner. If you compensate for that gyroscopic force by spinning the crankshaft in the opposite direction, it therefore makes it a little easier. So we're talking percentages here. The crank is spinning a lot faster than the wheels, but it's also a lot smaller. So anyway, let's look at the next step. So we've got the mesh is good. That's in. All of those are in. 47's in. The gear is in. Bearing, gear, the seal is in. Okay. 43, 42, 41, and 40. Now this is where I may need to put that bearing in the freezer. That's of course because when you freeze metal, it contracts. It doesn't contract a lot. I mean, you can't tell, you can't see it, but it is a measurable amount. And if you're trying to fit a bearing inside another steel surface, the easiest way to do that is to freeze the part that goes on the inside. As it warms, it'll expand, and in this case I suspect it'll create the perfect press fit. The other part of that is typically to put the outside piece in the oven, warm it up, but you can't do that if there's a seal, a rubber seal in it. So we'll We'll see if this works and take it from there. So let's do this piece. So this is the bearing. Unfortunately, I didn't think to measure the ID here. Got the micrometers to do that, but they're with the work table. Okay, spacer, aiming it as shown. Drive it fully home, O-ring. Insert the washer with writing facing out. And there's no writing on this one. Great. Okay, so does that mean that this is not the right part? This one has writing on it. But even based on the drawing, it doesn't look like the right one. Good Lord. Having been a technical writer for many years, I hate seeing bad technical writing. And this is as bad as it gets. Oh, interesting. Oh, there we go. That slipped in very easily. I was worried it would take some force. God damn it. Is that the right one or not? It's kind of hard to tell. All right, let's do the one with the writing facing out. It's just not, it's not going to fit. It's going to push up against the seal. Well, I don't know for certain that this is the right or the wrong one, but just my feeling is that this is the right one. Yeah, we may have to redo this at a later date, but, well, that's just the way it goes. That's one way to find out. Okay. Now the bearing. Okay, so I'm not going to try to push it in, have it get jammed halfway, and then have a real mess and damage this surface here. So I'm just going to put it right in the freezer. So I'll go do that. Wait for an hour or two, and then we'll be back. How did this get so dirty already? Okay, yep, so I'll go put this in the freezer. Writing out. SKF, interesting, good brand. Okay, yeah, so I'll put this in the freezer. I'll get a socket that's exactly the right size, just in case it needs a little tap to go in. Yeah. And then take a break and be back when this is below freezing. Okay. Won't take long. Bearing is out of the freezer, and we are going to drive it home. The socket is the perfect fit. Oh, dummy. Okay. There we go. So easy. Well, yeah, actually, wow, that was as easy as it can be.